Are y'all looking at the page that says critical points? Okay. And then, so let's start where it says examples under increasing and decreasing. Which one? For increasing and decreasing? So the back of the one that says critical points, where it says increasing different, it's like number 5. Can I give you the definition of what, Slade? Critical points are maxes, mins, and zeros. You don't have to fill out that part, though. Extrema are maxes and mins. Direction. I feel like this is a test for me. Do you know the answers? Okay. So number 5, is that what we're saying we need help on? Number 10. Yes. Yes, some of them will not have one. All right, so this looks something like this. And I would too. I would look at this. I would say, do you want me to make you find it on your calculator? What? If you want to graph this on your calculator, go second trace to calculate and calculate the maxes and mins, you can. Oh my goodness. I'm on the first 10. All right, here's what I would do for this. If I'm looking for increasing, decreasing, I would find all the maxes and mins first, because maxes and mins are where increasing and decreasing changes, right? So I would look at this point, if I'm looking on this graph, it looks like it's about -1, 1. This point down here looks like it's about 1, -1. Does everybody agree? Okay. Do what? About, I'm sorry. Okay, it is precisely -1, 1 and 1, -1. All right, now read it like you read a book left to right, yes? So as I start out over here, am I increasing or decreasing? Increasing, because it's going up as I move left to right. We'll write the intervals in a minute. Let's just label the graph. Now, once I get to the max or min, that's where it changes. So from here, it switches. It stops increasing and starts decreasing. So all of this is, and in fact, even whenever you get right here, it's still going down. It never stops going down. Okay, it may not be going down at quite as fast a rate, but it's still going down. Okay, and in fact, it keeps going down until it gets to this point. And then it switches again, and it starts doing what? Increasing. Now let's write the intervals. So increasing, decreasing. You use X to write these intervals, okay? So left to right. So negative infinity to -1 is increasing. Yeah, we will in just a second. I always just go along the graph and put it there. If you do it all at one time, that's fine too. We're talking about increasing and decreasing intervals. All right, so now from -1 to 1, it's decreasing. And then from 1 to infinity, what's it doing? increasing again. So I'm going to join that over here with that interval. Yes. Number 6. Looks something like this. I'm just putting the asymptotes on here to help me draw it. All right. Given the intervals on which the function increases or okay, never mind, I've already seen that. All right, what am I doing left to right? Do I have any maxes or mins? No, right? All right, left to right. I'm going down, down, baby, down, down. Nobody. This goes down, and it's still going down. In fact, it's always decreasing, right? But there's one place, I can't say negative infinity to infinity because there's one place where there is no graph. -5. This is -5 right here. So I'm going to be decreasing from negative infinity to -5 and -5 to infinity. And increasing is none. Yes, no, maybe so. Is that a down or that's a sideways? I'm sorry. Increasing, decreasing? With the asymptotes like that? We're going to do a whole unit on graphing rationals like that. Graphing rationals that look like that. How do you classify what? Classify what? Relative max or min, or absolute max or min. Ten on find the zeros and y-intercepts. And also 9 on that one. All right, let's do the zeros first. Zeros are set equal to 0 and solve. So multiply both sides by 2, yes. 0 equals the square root of x minus 3. Square it. Where do what? If you multiply by 2, it cancels. But it's 0 still. Because 2 times 0 is 0. That's what I did. But like, we just take the primary root when we're talking about the graph. Now for the y-intercept, put a 0 in for x. That's how you do y-intercept, right? What's the problem? There is no y-intercept on this one. Think about, that's what that graph looks like. And saw that it was imaginary and there's none. Yes, honey. Yes, because that's not actually your y. If you put it back in, you should get 0 because it's sitting on the axis because you already put 0 in for y. So to put that in for x, you'd just be going back and redoing the same thing again. So to find a y-intercept, you put 0 in for x. To find an x-intercept, you put 0 in for y. Delaney, what was your question? Good. Any more questions about this one before I do the next one? I don't know. I think they said 9. 7? Y'all, I can't believe you're stumped on 7. I've helped a lot of you already with one like this, but that's okay. Solving the absolute value. All right, so x-intercept, I'm going to set it equal to 0. Yes. And if you think about it, it makes sense. Why? Because this is what an absolute value graph looks like, right? So it could cross the x-axis twice. I'm going to add 1. And now think about what absolute value means. Tell me what absolute value does. It makes it positive, right? So if this equals 1, or if this equals -1, right? If I put a -1 inside here, it's going to flip it back to +1 anyway, right? So this is how I set up my two solutions here. Well, you can without, if I do this, what does that equal? So if I made the inside equal to -1, it's still going to equal +1 at the end, right? It'll do the same thing. So add 5 and divide by 3. So 3, or divide by 2. 3 is one answer. Here, add 5 and divide by 2. Yeah. Those are your x-intercepts. Now for your y-intercept, put a 0 in for x. Yep, always. Absolute value -5 minus 1, which is 5 minus 1, which is 4. Yay. What else? 9? I don't want 9 anymore. Sure. You do want 9? 9 is a quadratic form. So I can factor it with grouping. What multiplies to 16x to the 4th but adds to -17x squared? So 4x, this should be 0 equals. Minus 16x squared minus x squared. I feel like we did this one, did we not? Take out a 4x squared, leaves me with x squared minus 4. Take out a 1, it leaves me with x squared minus 4. I have x squared minus 4, 4x squared minus 1, and now everybody goes to 0. X squared minus 4 equals 0, so 4 is plus or minus 2. You could, yes, you could. You can make this x minus 2, x plus 2, 2x minus 1, 2x plus 1, and 1/2. If I put 0 in there, my y-intercept would end up being 4. How did I do that so quick? It's the only constant in there, right? If you put 0 in for those x's, that's the only thing that's left. Absolutely. Yes. If there's no constant there, it's 0. If there's a constant, then it's huh? For calculators? What the? Oh, that? Yeah, I use it for calculators sometimes. What else on your homework? Is it not as hard as what you were making it? 8 real quick before we flip over. Yes. So on 8, take out an x first. I've got x squared minus 10x plus 24. What multiplies 24 adds to negative 10? Negative 6 and negative 4. So my 3 solutions are 0, 6, and 4. And then, of course, the y-intercept, if I put a 0 in for all the x's, the y-intercept would be 0. Yes. Yeah? How else are you going to factor that? How's that help you solve it, though? Which is the same thing I have, you just still haven't taken an x out. So at some point, you'd have to take it out, but yes. Charlie. If you don't have a constant on the end, it's always going to be 0. Ask now so you know how to do it on your quiz. It's just time. It's an easy one. It really is. Back page. Which one on the back page? 12. 12 through 20. Let's do 12. No, that's what time you leave, silly goose. All right, again, use the graph to answer the questions. Don't try to. So it says extrema. We're just looking for maxes and mins here. That's it. No, it just says give the coordinates and classify the extrema for the graph. For now, you can, yes. Yes. No, it doesn't have to have an absolute max. If they go off in both directions, there's no absolute. Yeah. Well, you would just say none. 1, 2, 3. What is this? Negative 3. 1, 2, 3, 4, 5. Is that absolute or relative? Relative. So I have a relative max at negative 3, 5. How about here? Relative min at negative 1, 1. That's all you had to do for that problem. That's it. You're done. It's not that hard, right? I mean, y'all are doing way too much. Yeah. If you want to put it in your calculator and then you want to hit second trace and calculate the max and mins, you can. No, I want to do that because I got I promise you. Y'all ready? Up or down what it does whenever it approaches an asymptote. It's really not bad. All right, let's talk about continuity first. Believe it or not, I'm probably going to get through this lesson and you'll have time to do You should have time to do all of your homework before you leave here. It's that easy. Give me 10 minutes. I don't even know that I need 10 minutes. All right, continuity. If a function is, I'm going to give you the basic definition, okay? This is the easiest way I know to say it. You won't change this definition until you hit calculus, and then we'll make it a little harder. A continuous function, continuous means you can draw, and I'm going to put draw in because you're not really drawing, but okay. Draw without lifting your pencil. That's what it means for the function to be continuous. Have we? Did we do holes and jumps and? Oh, okay. Oh, okay. We're gonna go a little more in depth now. All right. So if I can draw it, with everything we have done so far has been a continuous graph. Yeah. Everything we've done, like I mean, a parabola, right? That's continuous. A cubic. Continuous. See how I'm drawing it and my pencil never has to lift up off the paper? That's continuous, okay? Now we're going to talk about three types of discontinuities. Common things that make graphs be discontinuous. Dang, y'all. I got it. All right, discontinuity number one. These are types. Discontinuity types. Start with what? Oh, yeah. I didn't mean to. I'm sorry. The only thing we said was if a graph is continuous, it means you can draw it without lifting up your pencil. Okay. All right. Types of discontinuity. Type number one is a hole. There will literally be a hole in the graph. Maybe it looks something like this. I have to lift my pencil up because it can't be at the hole, right? It's not continuous. Okay. If this was on, I would say this graph is not continuous at x equals 1. Does that make sense to you? Because there's a hole. Everybody okay on hole? All right. I told you this was easy. Told you there's three types. That was type number one. Type number two? What? No, one is hole. No, that's number one. Number two is a jump discontinuity. Is there a puddle? No, but it is actually exactly like it sounds. It's a piecewise. Remember whenever we did piecewise and it's a piece of a graph and another piece of a graph? It's a piecewise that doesn't connect. So, well, sometimes they can. Maybe it does something like this. That would be a jump discontinuity. It jumps from one point to another. There is a break in the graph. Yeah. So this one has a discontinuity at x equals what? 2. Jump discontinuity. For right now, yeah, I told you it was easy. Tell me whether or not the function is continuous. If it's not, what type of discontinuity does it have and where? And then the last one is the easiest. It's the butterfly discontinuity. No, I'm just kidding. It's the infinite discontinuity. It's an asymptote. Right. So maybe I have an asymptote like this, and my graph comes up and does something like this. I don't know, whatever it is. There is, put my axes on here. 1, 2, 3. This one has an infinite discontinuity at x equals what? 3. I went 1, 2, 3 on those. Okay. Does that make sense? Can you see the discontinuities? Can you see how I could not draw that one without lifting up my pencil? So it tells me that it's not continuous. Where's the discontinuity? It happens at x equals 3. Easy enough? Yes. Let me just talk to you quickly about end behavior and I'll be done. I told you this was a 10-minute lesson tops. Yes. Discontinuity. Yes, and you tell what kind it is. We did a little bit of the next part in Algebra 2, and I'm going to just go back to these examples that I have and show you. If I asked you for the end behavior of this graph, what would you tell me? As x approaches infinity, f of x, which one is it? What is it? You said it. Yeah, that's it. Negative infinity, right? The right side goes down. I need the other end though. As x approaches negative infinity, what does the graph do? It goes up. That'll be on the back. It says describe the end behavior. Okay. Well, wait, let me show you if it, let me show you if it goes towards a value. Okay, thank you. Infinite discontinuity. So let's look at, and this is about, let's do one, let me draw one. Is this a continuous function? Why? What's the type of discontinuity? An infinite. You got questions? You're good. All right, so now what I want you to do, we know it's an infinite discontinuity. Where does the infinite discontinuity occur? X equals 1, right? Now describe the end behavior. As x approaches infinity, no. Two. It's just 2. Why is it 2? F of x is y. So as I go further to the right, this graph, remember this is an asymptote, it's getting closer and closer to 2, but it'll never actually be 2. So it doesn't actually go up or down, it approaches a value. So this time as x goes to infinity, f of x goes to 2. How about as f of x, or as x goes to negative infinity? It's still 2, it's just going from the other direction. Y'all see that? What's the right side doing? Well, it's not going up or down, it's hugging this line. What is that line? That line is 2. And that's it.